Okay, I think we can get started, right? We're at the hour right now. So thank you all for joining. Sorry for the confusion with timing due to this daylight saving. So we changed timing this weekend and that kind of screwed up all our settings. Anyway, so thank you for joining. I think this is our fourth show and tell, Jeremy, is it?
Fifth.
Fifth, okay, number 5. So it's always very interesting to learn about your project. So what do we have in the agenda today? We have 4 talks. So the first one is going to be by Fatmaliza and Syafiga from Indonesia, from Universidad of Indonesia. And it's going to be about automation of coloring process in fashion design using the Arduino color sensor. Then we're going to move to Hilal from Iraq. It's going to be about anomaly detection for a faulty motor using the Arduino Nano 33 BLE. Thanks. We're going to then move to Latin America with Edwin from Dominican Republic, which organized a TinyML workshop, and he's going to share his experience in organizing that as a first-time, TinyML activity. And last but not least, we're going to have Mohammed from Pakistan about voice-activated LED lightning control. So that's the agenda. But before getting started, let me remind you about the next activity we're going to have, the workshop running in April online. So the title is Workshop of Scientific Use of Machine Learning on Low-Power Devices, Applications, and Advanced Topics. It's going to be 5 days long, 3 hours per day with a very interesting agenda. And the deadline to apply is April the 7th. So we have already more than 200 applications. It's going to be lots of people from all over the world, from many different time zones. So we have to make sure we get the timing right. And as we're going to cover advanced topics, I really think that's going to be very interesting for you to join. And that's enough from my side. So we can get started with the first speaker. So Fatmaliza, if you want to share your screen, you can do it now.
Thank you for having us here. It's an honor to present our idea to you. So our presentation today will be about automation of the fashion coloring process using Arduino's color recognition. The first part of presentation will be presented by me, and the rest will be presented by Fatmaliza. Next. So let's go to the background first, why we have this project. So when designing something, especially in the sketching process, a fashion designer needs to change color or pattern in the design with the aim of finding the color that best matches the model being designed. By doing it manually, it's inefficient and will take more time, while the time is crucial in fashion design. So shortening the process in this process, it will be very helpful and useful in the long run process. Next, thank you. So as I stated before, manually changing color in the sketching process would make the process to take a long time to finish. Therefore, we need a technology or machine that can automatically input the desired color into a digital sketch on screen. Now, you might think that we can do it in digital sketch in a tablet or PC, but to do that, you still need to manually changing the color. So in this project, we propose a system that can catch real-time data of color and transfer it directly into the screen through a color recognition in Arduino. So this way, we can minimize mistakes in sketching and increase the time effectiveness. So how is this system work? This will be explained by Fatmaliza in the next slide.
Okay, for the next slide, we got the tools and the materials that we need for this project. For the first one is a glass. So in order to build the machine, we have to make surface for the source, the color source, like the pepper color source and the light the next one is the light. After that, we will need Arduino Nano 33 PLE to detect the RGB color from the color source. After that, we need the 3D printer for printing the case, like the machine case, for the surface, like for like the glasses and stuff. After that, we need a monitor to show the sketch, like the PNG sketch, and then so that we can also see how the color and the sketch match. After that, we need the cable to connect the Arduino 33 to the monitor. After that, so I'm gonna explain the mechanism of the machine itself. So the first one is like the color or pattern source. It could be any fabric or like just could be like a paper, and being identified by the sensor in Arduino Nano. And then Arduino reads the RGB color values from sensors and then send it to the sketch. But before that, because the RGB value could not directly appear on the sketch, on the coding itself, we will use P5 serial control to convert that that value, RGB value that have been collected by the Arduino Nano to put into the P5.js website, where we put our code and how to make the coding and the sketch itself. So we could connect it to the sketch. And then in the P5 itself, we also put the line art sketch, should be in PNG, so that the color from the sensors could display it in the transparent area where you need it. And this is the prototype. So this one is, we tried the prototype, and we try to connect it with P5.js. So as you can see here, the color is changing based on what we put from the paper, the color paper that we put above the machine. So this is the machine, as you can see it. We put the glass here, we put the light on the under the glass surface, and then after that we're gonna put the paper like above here, and we could detect it with the Arduino, and then we could connect this cable to the P5. It's like this. So we could, so the color is quite accurate, as you can see it here. Yeah, I think that's all from us, and thank you so much. Is there any questions or reaction? All of you guys could feel free to get in touch with us through our email. Thank you.
Thank you.
Thank you.
For that, I'm going to add a little bit. So this is what I meant by, if you have a digital sketch in tablet or PC, you still change it manually, like you change the color. But with this system, you just need to put the paper in the surface and the color detected, and as you move the paper, it will automatically change the color. So it will be more efficient for designers to have this while working. Thank you.
So thank you so much, and there's an applause here from my side. Really, really, really interesting and new idea. I never heard about something like that. So that is really, really interesting. So let me ask if there's any question, or I have one question. Jeremy, yeah.
I have a quick question. Oh, well, two actually. Good for you guys getting P5 working so smoothly. That's really excellent. Do you find, and here's a suggestion, if you change the intensity of the light, the color changes automatically, does it? At the moment, is your light just got one intensity, or is there a way to make it brighter or darker?
Yeah, actually, for the light itself, it's quite sensitive. So when we like put a little bit like intensity of the light, it will change the color really quickly.
Yeah, that's a really, really interesting project you've done, because you've got lots of options there with that light to change its intensity or even change its shade. And then you're now changing what you've got on your screen as well. Yeah, that's a good use of the Nano 33 color sensor. And as Marco says, it's a kind of a new way of looking at it, different than most of our presentations. Anyone else got stuff to add?
Well, I have one question. So you said you use these colored papers, right? So have you tried, different types of, papers and materials and stuff? And how does that work?
We had many experiments with the paper itself. At first, we used like a really thin paper, like HVS paper, and it's kind of not like really, the color is not really strong, because the thin, like it has to be really the paper has to be really thick, not really thick actually, it's like thicker than like the ordinary paper, because it will not show like the color of it if it's really thin, because the light will go through it.
Yes.
And yeah, so we need like a little bit thicker paper. So
Yeah.
we got really we got experiments for like many paper fabric. Yeah. Like
Excellent.
Do you have a system where you can have the light reflective for a color that's not see-through? Because that would work as well, wouldn't it?
It could be both. Oh, that's why we use the glass, I guess. Yeah, so it could, so like the light could spread to, it's not really reflective, is it?
Yeah.
Some things to think about.
Yeah. And just wanted to add something which I really like, the fact that you use the 3D printer to build, part of your component. So in most cases, it's only used to build enclosures, which is interesting, but you could do it with another type of box. In your case, the 3D printer is really useful to set everything up in the proper way. So congratulations for doing that. Really, really nice. Okay.
Just a quick extra question. Both of you, do you have plans to kind of do a little bit of the machine learning with the color, or at the moment are we sticking with sensor, P5, get it on the computer? So that would be something to be looking into later on. Any ideas on that?
Yeah, I think because this is just only the prototype, we still need a lot to explore, and I think that's a good idea to be put in our project. Haven't had the idea yet what to input with the machine learning, but we've considered it.
Yeah. Well, thank you for presenting
for the suggestion.
Thank you.
Yeah,
thank you so much
for presenting a novel idea.
Yeah.
Problem, Marco, is I haven't heard from
Hilal is online. So
okay, excellent.
We have the second speaker. So yeah, Hilal, nice to see you. If you want to share your screen and
thank you very much. I'm happy to be here with you. This is a great group of machine learning with TinyML. This is actually a very new object or topic in Iraq. There's no many researcher or student working on it these days. So and it was very kind thing from Edge Impulse to send me a set of tiny machine learning kit, which I am using with my student now. I'm teaching in the University of Babylon, one of the universities, government universities in Iraq. I have 3 groups of graduation students working on this machine learning topic. One of them, which I am showing today, I'm showing this or presenting this on behalf of my student. They are not very comfortable talking with English, so I am doing this right now. Let me share the slides. Hope this it's online right now.
Yes,
the slides.
Perfect. Yes.
Great. So today I'm happy to sharing this experiment of our graduation project for end year in Babylon University Electrical Department, which is working on how to detect anomaly for faulty motors using the Arduino board Nano 33 BLE Sense. So the anomaly detection is how to detect something different from normal behavior. We are talking here about motors and electrical machines. So if there is any anomalies that can be detected from motors, which is involved in what call it predictive maintenance, usually in industry, and especially in this is a smart industry, they call it Industry 4, where the Internet of Things and AI are involved in managing the factories. So they are looking for smart sensors or smart devices that can help to make the predictive maintenance easier and less cost. So usually we have to sense some vital signs from the machine. Here in this project, we are working or detecting some of features like vibrations features, which is come from accelerometer and gyroscope, which they are already exist in some boards like this board. We are working on it. So predictive maintenance is very important issue in Industry 4. And anomaly detection is one of the keys that make the predictive maintenance. So what we did in this project, I am thanking Gimpulse for sending this 10 kits of tiny machine learning kits, which are working on anomaly detection. Another project is speed estimation, and the third project is voice command response. In this project, we have set up an experiment of 10 brushless cooling fan. This is like 12 centimeter by 12 centimeter in size. And these brushless usually using for cooling in servers and desktop computers. These 10 fans are working on 12 volts power supply, and we are using DC to DC converter to make 3 different speeds. One is the full speed, which is one on 12 volt, and others on 8 and 6 volts. And use the Arduino 33 BLE Sense and analyze the data on Edge Impulse platform. And these we are collecting data from these fans by putting the Arduino board. This is the Arduino BLE33 on the fan itself and collecting the vibration. These boards have 3 types of sensors. One of them is the accelerometer, and the other is gyroscope, and the third is the microphone. Here in this experiment, we use just two sensors, the accelerometer and gyroscope. We are collecting data by sampling the vibration every second and upload it to the Edge Impulse platform, which collecting data about 100 samples for each speed. And we make a default by hand with put some oil on the fan, or pinch the fan from the edges to make some faulty motors, and check if this will can be captured by the accelerometer. Now they are collecting data. The experiment is not finishing right now. So we use 6 fans, which is normal, and 2 of them faulty for training, and test the system for 4 fans. 2 of them are normal and 2 faulty, and check how the performance, check the accuracy, the F-score of the output, and if the system will work for. It is not finished yet. This is a little video to see how this how we mount the accelerometer on the board on this. This is the faulty one. You see, this is some of the this is one of the speed. So we are now in collecting data, and hopefully within 2 weeks we can finish the experiment and analyze the data and see the performance of the whole system. So this is what I'm showing right now. Thank you for listening, and I'm waiting for any questions. Thank you.
Thank you so much, Hilal. That was great. An applause here from all of us.
Thank you.
So, any questions?
I will send this for my student. How you respond to this? Thank you.
Quick question about the experiment. Using the accelerometer and the gyro, are you doing all 6, like XYZ accelerometer, XYZ gyro?
We use 2 of approaches. When we get the what I call it, square them and then take the root. This is like the magnitude of the 3 axes of the accelerometer, and other we take every axis individually and see which will give us the best system performance.
With your setup the way you showed us, which ones are giving the more interesting data, X, Y, or Z? Does that make any sense?
I guess the Z accelerometer gives us the best anomaly detection, especially when there is fracture in the fan. So it will be very clear in the Z axis.
With the gyroscope, are you also doing all 3, or not using the gyro at all?
No, we are working now on more than 1 model. So one of the model is use each sensor individually, like the 3 of the accelerometer and the 3 of the gyroscope, and 1 for the magnitude, and then 1 for accelerometer itself, and the other for the gyroscope itself.
That's great. Hopefully you can present another time once we've got some of the data done. Anyone got any questions for Hilal?
I have one, Hilal. So
yes,
how much data are you collecting? This would be the first one. And the second one, given that all members of our network have the same hardware, it would be really, really, really nice to be able to share that data. So, someone from some other part of the world that doesn't have the fund would be able to use your collected data to then do their modeling. In fact, I think this is something that we can really work on in the future. Oh, I think we lost. Okay.
Sorry, it was freezing.
Okay. So my question was about how much data do you gather, or have you gathered? And second one is if you're interested in sharing that data so that other people from our network can then use your data on the same devices to do the modeling.
Sorry, it was freezing. I think I get out and came back to the. So if you repeat the question, please.
Okay. So how much data are you gathering? Or
we have a 3 speed. Each speed we collect 200 sample. So in total, it will be 600 sample. Each sample is 1 second in length in time, with the 6 axes of the accelerometer and gyroscope.
And the second question would be, are you willing to share that data so that other members of our network that have the same devices can then use that data for their models?
Sure. Now we have an account on Edge Impulse. When we finish the experiment and get the result, this will be all available to the public, and hope to get another result from another group, and we'll be happy to check if this work is going well.
Excellent. Fantastic.
Okay. Edge Impulse does allow quite an easy way of sharing your Edge Impulse model. It's quite simple. You just click share. But what is confusing is you then need to tell people about it. I don't think Edge Impulse has a way of saying all these things are shared. So when you are done.
So my student, they will have like a graduation report. This will be in public. And another thing, there will be videos, how they are set up the experiment, how they collect the data, how get the analysis from the Edge Impulse and the figures and the performance metric like accuracy score, F-score, precision of the result of this experiment. This will be all be in public, hopefully, at the end of April. I hope.
Good.
Excellent. Thank you so much, Hilal. That was great.
Hello.
Yes.
Thank you.
And I have a question to ask him.
Yes. Go ahead, please.
Please, I want to know if you account for environmental, like some kind of noise in the system, because I think you place the fans on the table. So do you account for if the table also shakes or something like that?
Thank you. That's a very clever question. One of the experiment, we have 10 fans. So usually you are working on 1 fan, but for noise and to check if the system will be robust against noise, we are making the other fans working, and we are collecting from one of the fans. And we didn't get the result yet, but I'm sure it will affect the score of the performance. But hopefully, it is still in the reasonable margin of the result. So the noise comes from environmental in the lab itself, like air conditioning, like fans in the ceiling in the labs, and the other fans which are not involved in the experiment, and check how this will affect the performance of the system or the network we are deployment.
Okay, thank you.
Question.
Okay.
Shall we move on, Marco? I believe Edwin's here somewhere.
Okay. Hello, everyone. Good morning, good afternoon to some of you. My name is Edwin Marte. I am from Dominican Republic. I'm going to share with you our first experience with the TinyML kit that we had basically on November past year. So to put everything into context, Dominican Republic is an island in the Caribbean, for if you don't know where it is located. I come from the University Tecnologica de Santiago, UTESA, which is located in Santiago, the second largest city in Dominican Republic. At this moment, I am a PhD student in the University of Florida, but I was a faculty for many years at the university. And at this moment, I'm working with 3 faculties constantly on the university. At the moment, there was not, that we know of, no machine learning or AI courses in the university or in the country. I know there is one from computer science, but it's very, very basic, very simple. There is not knowledge of TinyML in the country or applications. And the most important thing is that there is no master on applied engineering in Dominican Republic. And those are the little things that we want to change. So by the time that Edge Impulse offer us the kits of TinyML kits, which we are very grateful of, we set some goals, short term, midterm, and long term. The first thing was training engineering instruction in TinyML, and we did that in November. Then we want something that we started now, to upgrade the programs to include TinyML, like in microprocessors and other courses. And in the long term, our goal is to create a certification, a specialization, or even a master program in IoT, remembering that there is not an applied engineering master in the country. So what we did past November is that we surveyed participants. We created a Discord channel. Basically, we got 2 instructors willing to participate, 18 participants. We provided them a 2-day training and a conference open to the public about TinyML. That was a really meaningful activity for us. We got it like 150 people which attended the conference. It was very nice. The agenda for the workshop included the overview of TinyML. We provided resources for machine learning at the University of Florida, because they have plenty of stuff, links and resources to Python and machine learning, applications of machine learning in research, and then an overview to the TinyML kits, and then we review study cases. For that, for the overview of the TinyML kit, we with the students, with the participants, we guided them to install the Arduino to create a basic program. We configure Edge Impulse. We created a project using the movement. The students repeated the experiment, conducting data collection, and then the very next day, we had the conference. The project was about mechanism for transportation, the very same program that we use in the training with the ICTP for the 3 type of movement. The students were able to replicate this project, and also they did the data collection. First, they did it with the data that was provided in the Edge Impulse that I have a copy of, and then they did the data collection and they created the project. We also created a repository where all the information, all the presentations, and all the data is. So during the conference, we review a couple of study cases, like the bearing failure identification system, basically all of them using Edge Impulse, and it was very useful and exciting for many people that provided insight how they can apply this knowledge in real application. The second one was the temperature from sound. This was the favorite because it was classification saying if the water was cool, hot, or cool or hot, depending of the noise produced by the water. This is really my favorite of all. We also review test of sobriety, in Spanish, borrachera. So it will say if the people were drunk or not with 2 legs. And also for the electricals, we review a project for identification of electrical charges by current signals, using electrical devices electrical sensors to measure the current. All of the projects were using Edge Impulse. So something important that we did in the survey, we made the participants to commit to a 20 hours voluntary work in the electrical labs at OTESA after the workshop. So after that, they have created by themselves a couple of projects. They are working on this. For example, one project that they are working on is occupancy sensors by using video feed on electrical labs. Basically, they want to control the lights and illumination. They want this to be automated. UTESA has 5 campuses in the country and more than 50,000 students, but the scope is limited just to the main campus. So they want to control 10 labs. And for this project in specific, as the cameras are in network, they planning to use a Raspberry Pi and H-Impulse. They want to take the real-time feed from the cameras and make determination if there is people or not on those labs to control the illumination. You need to know that UTESA is a university. The most of the courses take place at night, so illumination is something meaningful for the university. The other project that they are working on, something else that you need to know, Dominicans are loud. We speak like most of Latin Americans, we speak high, loud. So sometimes that produce some problems to in the university environment. So they want to warn people when they are speaking or producing noise at high level in the proximities of the electrical labs. So they are conducting that calculation. Their goal is to classify people related noise in lab proximity, and they are using the TinyML kit and H-Impulse. We are not telling them that, they are open to do whatever they decide to. They have many challenges in these 2 projects. We provide feedback if they ask to. We want them to have their own experience. So sometimes are difficult, especially that one with the noise. There are many noise related to this one that could go wrong in many ways, but they are working on that. So we are very grateful that this group is trying to do these projects, which are not for beginners, after just this workshop. So that basically is our experience. We are very grateful to ICTP, H-Impulse, and the whole network that have made it possible for us to conduct this workshop. Thank you.
Yeah, thank you so much, Edwin. An applause here from my side. That was extremely interesting, and I think, yeah, what you achieved is really, worth sharing, and this experience. Any questions? Jeremy, do you have any question?
Really like what you're doing, Edwin. You've come up with some creative ideas. I love the 20 hours volunteer work, and your Nano 33 BLE setup from either from Edge Impulse or from our group. That's a great starting point, right? I think you're doing exactly what we want lots of people to be doing. Good for you bringing that in.
Thank you.
And now, after Hilal's presentation and your presentation, and I'm thinking that really we should share this data that we gathered. I'm thinking about the water temperature, right? And that is something I shared the link in the chat that we did with Marcelo, about 1 year ago, and we gathered some data. So you have other data, and there's other people that are doing the same experiment. So I think if we can have like a larger data set, then we can use it for the next trainings. So we don't need to have people, pouring water, but they can train the system with the existing data set, and then we can just run the experiment. So I think for the next months, we should keep that in mind. Excellent. Thank you. Yeah. Thanks again, Edwin. And last but not least, we have Mohammed from Pakistan. Are you there, Mohammed?
Okay, so this was our project about the voice activated LED. Anas, can you further proceed the slide?
Okay.
So the main motive behind the project was that we want to eliminate not just eliminate to eliminate the common touch points, as we have earlier experienced the spread of virus. You all know that COVID-19 was a very deadly virus. So the main motive behind this project was that, and also help the people with physical disability to reach their common touch point, like to reach their switches for fans and appliances. So this was through their voice only. So this was our main motive behind the project, and this was our class project. So we are very thankful for TinyML to providing us the kit. Next. So the edge impulse training we did was, first we acquired the data, then a training model. We selected the training model, and then after that we used the live classification and testing for the data. So these for the data acquisition, we acquired the data through the microphone of our mobile phone, and we classified that data into 4 types. So for example, if you want to turn on the light, so you just have to set the light on. So Anas, would you play that?
Light on, 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 light off, 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 light off.
So it was and the noise was about actually in where we live, there's a very noisy place. So then adding a noise classifier to it was very helpful for us too. So next. So this was the model as recommended by the Edge Impulse also. So 80% of the data was used for training, and the 20% was the test, and we acquired this type of data. Now, Anas, you can proceed.
Okay. So for the model selection, we use the keyword spotting algorithm as we used in our data. We have the basic keywords like light on, light off. So it's a basic keyword spotting algorithm, and we got a very good accuracy of 78.6%. We trained this model on the TinyML Edge Impulse, and after the training, we then move towards the live classification. In the live classification tab, we check that our model is trained or not by testing it using the microphone. Then after the testing, we downloaded it Arduino IDE library, and as our hardware is the Arduino Nano 33 BLE, given in the Edge Impulse kit provided by the Edge Impulse. So we simply downloaded its library, and then we execute the microphone code of the Nano 33 BLE, and then after executing, here a video demonstration of how our project goes. So for the then for the demonstration, so we simply add our library on E and changes, and after loading the code on the Arduino, so here's the hardware demonstration on Arduino Nano. Light on, light on, light off. It's the video demonstration of our project, and then for the future application, it will convert it into a smart socket, and the smart socket and can be widely used in the home automation areas. It could it's a very not very complex circuit for the smart socket. We can on it can easily be converted into a smart socket by adding a relay and a converter, and the schematic layout is as follows, like this. Thank you very much. Any questions?
That's interesting. You're mentioned with the smart socket. Good job there with the light on, light off. I'm curious if there is a smart socket out there with a digital input to make that kind of thing even easier for you guys. I noticed you set up your own relay. Any opinions? Yeah, the smart socket here, you've done your own thing. I wonder if you can buy a smart socket that simply has a 3-volt, 5-volt input.
Yes, we can, but as we said earlier, it's our class project, and we don't have so much resources there. We have just to use the Edge Impulse kit.
Yeah, good for you getting that
That's why
working.
we use our creativity.
Any other questions, anyone?
Yeah, I have a question. Hello.
I have a question.
Yeah, Hilal, go ahead.
Oh, thank you. It's very interesting project. Actually, one of my students do the same thing, but earlier, not this year. My question, which is a challenge for me at that time and my student, is the voice is just respond to your voice, or it's a command from any other person who can pronounce the same command, like light on or light off.
Okay,
It will
okay.
respond correctly, or
would
just
like
for your own
to-
voice?
So I would like to answer that question. We trained this model over multiple voices, and in our university, we collected a sample of 10 students. So we requested them to just pronounce it for us multiple times so that our data could train. So this project was also reviewed by our instructor, and he also performed the same, he also pronounced the sentence like the light on, light off. So it was working there also. So it is not confined to only our voice, but anyone can do this.
Thank you. Thank you very much.
I think Dennis had a question.
Yes, and I think it's the same as Halal actually asked, because I wanted to know how diverse their data was. Did they actually collect data from outside? I think they're in Pakistan, right?
Yes.
Yeah, so do you collect some kind of data outside Pakistan?
For this current project, for this instance of time, we don't have that much time to collect the data outside the Pakistan, so that's why we not collected that. But in future, yes, we should do that.
All right. Thank you.
I have a question for Anas's group. You've done 4 words. What do you think on the Nano 33 BLE is your maximum number of words before they start getting confused amongst each other?
You're talking about like their light on, light off, noise and nothing, these 4 classes?
Yeah, how many more do you think you could have? Could you have fan on, fan off, or are things going to start getting confused?
Okay, so according to my point of view, like Nano 33 BLE is a very small sensor but very capable sensor for the machine learning. So I think we can add 10 to 15 words in it, and then we have to test, but I'm not sure about it because I've not tested it yet, but definitely I'm going to try it. It's a very good question. I'm honestly trying it. Okay, thank you.
Yeah, good, great extra study. I think the 4 words was the best starting point, and the noise and nothing is a good one to have as well. Yeah, good work.
Thank you.
Any other questions for either Anas or for the whole group?
Okay, so if there's no more questions,
Okay,
I think we can close this show and tell. Again, don't forget about this workshop in April. Ask your students and colleagues to apply, and apply yourself, of course, if you're interested. It's going to be extremely interesting. We have some very, very good speakers, so I think it will be a very useful and interesting experience. Jeremy, you want to add anything?
Just if you want to present, you do have a deadline for the April conference. I think it's April 7th. But if you just want to watch, it's a virtual conference, similar time to now, plus or minus an hour. It'd be great if people could touch base, even if they can't do the whole thing.
Yeah, let me add the link with the application form. It's here in the chat, and the apply is on the left. So if you want to apply, you click on apply here, and you need to enter your information the first time you apply, and then, you know, for other HTTP activities that is easier.